Today we are going to see that how to do the programming in the FPGA device by using the Vivado design chute. Basically, this is the FPGA device which we are using to download the programming. So the device name called XC7A35T1CPG236. So each and every part, it is a definition is there. 7 RTX device we have used that, and the number of IOs 236 IOs are there, and the commercial device. This is the device. Is the commercial devices we have selected. This board actually by using our programming, we are going to do that small AND gate. That is a simple AND gate. We are going to use that by using these two switches and one LED. So our application is based upon one simple AND gate. We are going to download by using the Vivado design chute. Okay, see, basically before downloading, what kind of software we have to download that Vivado design chute software from the website, Xilinx website. Maybe at present 2022 versions, 2023 versions also available. So, but what kind of software you have to select for using this kind of operation, then you have to check with your system configuration also. Basically, the minimum 16 GB RAM is required and 1 TB hard disk is required and recommended for this for those softwares. And what kind of device we have to select? This is based upon basically depends upon the what kind of application you are going to use that. Maybe you can use the small AND gate, OR gate like that, or else you may go for any kind of analog to digital conversion or 7-segment display or VGA operation or any USB operation or any high speed serializer and deserializer work. So all those things should be based upon the system specific. So you have to before selecting the device, you have to be careful what kind of application and what kind of board which we are choosing as well as the device. Okay, so now we will go that the software already which already I have downloaded. So here this one, this is that software Vivado 2017.1 and 2022.1. All the operations are same only, but minimum some more advantages are there in the 2022. So at present we can go here for creating the new project. Okay, file, new project. So create a new Vivado project. Okay, next. So the project name, I am going to give that hello world, which is the common at any more places. Okay, so hello underscore world. I am doing like this. Okay, so the project location we have to give. Next. So here many kind of different things are there, but we can go for just a small RTL project only. So RTL project. Next. So here, if we have already code, we can go with that. Otherwise, we can create. Now we are going to create that file. Okay. So either Verilog or VHDL, you can choose it. At present, I am going to choose that VHDL. So the file name is andgate.vhd. Okay. So now the file is coming here, and then next. So constraint, at present we are not going to add any kind of constraints. Next. So the device selection already I told that XC7A35T. Okay. So out of that, here what kind of device we are going to connect? This one 236-1. Okay, there is a commercial device which we are going to use that. Next. And nothing need to do here, you just understand. So at present no constraints are added. Okay, so the device, so what are the devices selected for this? These are the informations are there. Finish. Okay, would you already suppose if existing project is there, do you want to close it? Yes. Okay, now the new project is coming. Yeah. Yes, AND gate architecture name is behavioral. Okay, so here I can give the inputs as well as outputs also. Okay, if we have the existing code, no need to give at present. In the AND gate, in our case, we are using that 2:1 output. So 2 input and 1 output. So the inputs we have to give the name A as well as B. Both are inputs. And the C output, this is the C output. We have to specify the direction, that is out. Okay. Now it is okay. So this area sources we have completed RTL, but we have to specify the exact functionality. So just double click. See here C less than or equal to A and B. By using the data flow modeling, we are defining the functionality. Just save it. Next we will go for the simulation, that is we call it as a behavioral simulation. In that behavioral simulation, if any error or any kind of syntax error is there, it will be listed out. Otherwise we can check our functionality. Our functionality, that is a 2 input 1 output AND gate. Now it is running. Check here. So this is the simulation waveform window. We can maximize it. See, basically 3 IOs. So we have to drive the values. The signal A, I am driving by using the force constant. So I will make it as a logic 1. And B signal I am just making as a logic 0. So the output will be logic 1. If I am clicking this button, it will run 10 microsecond. Okay, now it is running. You can see the output will be 0. Now I will make again the value of B, I will change it to 1. Again I will run. You can observe that now the output will be 1. So the functionality has been, if we want to verify all the values, we can change these signal values and we can verify it. We have the certain kind of zoom and zoom out, all the points are here. We can verify it. Suppose if we want to do by using the test bench, that also possible, we can do that. Now we will go for RTL analysis. Just we will go for any elaborated design. We can see that by using this, we can see that RTL schematic. Just double click. Yeah, it is going on. So we have to wait. Okay, now it is okay. So IO planning and everything is also coming here. Okay, first we will go with the schematic. We will see, yeah, this is the schematic window. We can see that. Okay, so just 2 input and 1 output. Okay, if you are going for package, if you are clicking, then you can observe that the IO pins we can define. Okay, here there are 3 inputs. Okay, 3 input, but the pin number, already we have defined that V16, V17, those are inputs, and U16, that is the output. Okay, that assignment we have to do. And one more thing also we have to do, like standard IO standard. There are many standards are accepted by the FPGA device. Now we are choosing that LVCMOS 18. Okay, so pin number we have to assign. Okay, either we can type here or else we can drag and drop at the particular pin position. Okay, suppose I am dragging here and V16. Okay, so another B signal V17. V17. Okay, so the output will be U16. U16. Okay, all are defined here. Okay, now you can just press the save button. Okay, now the XDC file name is it is asking. The meaning is we have to specify the Xilinx design constraint file. Okay, so these all are stored will be in a file, we call it as a XDC file. Okay, in the source window you can observe, in the source window by clicking here. Okay, then the hello world.xdc it is coming. If you are double clicking, then the text file has been opened. Here it is mentioning clearly set underscore property IO standard LVCMOS 18 get ports A. The pin assignments set underscore property package underscore pin V16 get underscore ports A, B, C, those are nets. Okay, now pin assignments are has been over. Next we will go for synthesize. Synthesize, that is a process used to convert our design into netlist. Okay, just double click. If you want to set anything, we can do it. At present we are not going to do anything, just we are clicking the synthesize button. Already it is running. Okay, so here we can observe. Okay, now these are ready. If you want to see the summary, you can click here, you can see the summary. Okay, timing and power utilization, everything will see here. Okay, in the next upcoming videos we can see that a detailed analysis of synthesize report, timing report and power report. Okay, now here implementation side. So further process it will run. So it is running now. Already we have defined IOs and everything. RTL design is ready. Xilinx design constraint file also ready. Now we have to, the final option, it has to check with the device and everything. The last process is waiting. That is for bitstream generation. After that we will download. Still it is running. You can see by seeing in the right corner, top corner, you can see that whether it is running or not. In the implementation also having a many process, so those are we'll see in the later stage. Meanwhile, just I will connect the board. I have connected. Next thing is program and programming part we are going to do. It is running. Meanwhile, we can see that the bitstream file generation. Okay, if we want any bit file or bin file, so if we want to bin file also, we can click this option. At present, we don't want bit file. By default, bit file will be generated. Okay, so if you want to do any other option, just right click and you can check it. Okay, now open hardware. Now target has been is there. Okay, if you are clicking, the option will come auto connect. Already I have connected the USB port to the our already interfaced with the device. Auto connect. Still one more point is the stream file need to generate, bitstream need to generate. So auto connection is okay, but bitstream we have to generate. Just click here. Okay, but unfortunately it is still design is running. Yeah, now implementation successfully completed. Open implemented design, we can open it. Now generate bitstream. Okay, then okay. Now the bitstream file is going to generate. Running, right corner you can observe that running right bitstream. Certain duration we have to be patient based upon our system configuration and these things, so it may be delay also, but no need to much worry about that. Be patient, automatically it will come. Now the file has been bitstream generation successfully completed. Okay, now everything is okay. If you want to see that report, we can see that. Okay, at present everything is okay. Now we'll go for the target file. If you want to open, we can see that how it is connected and everything. Okay, now some survey it is asking, we can go later. Now bitstream is okay. Now open hardware. Now we can, if you want to change the target device, we can change it. Now program device. So XC7835T_A, our device, we can click it. Okay, program. Now you can observe. You can observe here the two buttons. So V16 and V17, the output will be U16. So by using all the options we are doing,